calculator, but it says that you can use a calculator if necessary, and I see some of the answers are not something you're going to just come up with off the top of your head, so I know it's going to be necessary. I just haven't done any of those yet. All right, so the first ones say the polar coordinates of a point are given, find its rectangular coordinates. So they give you a graph, or well, I say they give you a graph. They give you like a little axis, and then they have a point on it, and they tell you that that point is at -4 and then 5 pi over 4. So just for reference, this is r theta. So we need to find the rectangular coordinates for this. So it's kind of weird the way that they've ordered this book, because they like have you do this, but then they don't actually have you converting from polar to rectangular till like later in the section. So it's just kind of interesting how like it all plays out. But anyways, they're just out of order. So what we do is we go back to these conversion formulas here. So x is r cosine theta and y is r sine theta. So it'll be r cosine theta. So this will be -4 cosine of 5 pi over 4. So what is the cosine of 5 pi over 4?
Square root of 2 over 2.
Yep. So we've got -4 times negative square root of 2 over 2. So then we would reduce that. It's going to become positive. So that's going to be, the x coordinate is going to be 2 root 2. Then the y is r sine theta. So this is going to be -4 sine of 5 pi over 4. And what is the sine of 5 pi over 4? Negative root 2 over 2. So this one happens to work out to both be the same. So that's going to be 2 root 2 as well. So then we would write it as a coordinate pair of 2 root 2. Whoa, that was a bad root. And 2 root 2. And that would be the answer that they're looking for, is basically just rewriting it. As far as I'm concerned, when you do these problems, if you don't want to like draw the little axis, like you don't really need to, just write down whatever that original point was, because I mean, for the sake of what we're doing, other than you seeing visually where that point is, it doesn't really do anything. And you're probably also thinking like that's negative, but it's over here in the quadrant where everything is positive. But part of that is because of where the angle falls, which is why, again, I don't really like how they do this in order, because the next stuff, like the next set of problems, actually having you like plot the point so you can see why this is negative, but it's in quadrant 1. Oh. Because where is 5 pi over 4? 3. So it's down here. But what they do is they actually say, because this number is negative, it's like, okay, well, that angle's down here, but we need to flip it. So that actually is up here. So it tells you it's like opposite of wherever it should be. At least, now, the book doesn't explicitly say that in writing, but every single problem that's been negative, that has been the case, as it has flipped which quadrant it's in, like by 180 degrees. Because, I mean, they're equivalent in a sense, but... So that's one of those things I would like to get some more clarity about, because it's kind of weird. Like, you wouldn't think it would be that way. And also, historically, r hasn't been able to be negative, because that's what we would consider our hypotenuse value, and we can't have a negative value. But obviously in this, it's a little different. So I'm sure it has to do with the fact that it's polar versus rectangular, but it just seems weird to me. And I'm just like, I don't remember this from when I learned this in college. So I feel like need to just do some verification here, but all the problems are like that, so I guess it's right. Yeah. But that's the only thing I can come up with, is it's negative, so it's flipping it, and that's why. Because literally every one of them is like that.
Maybe you can make like a theorem about that or something.
There probably is, and I just don't know it, but...
Queen's Law.
I don't know about all that. Alright, this one, they put the point like right here. And it is -1 and 315 degrees. So, see again, 315 degrees is where? Quadrant 4, but it's negative, and so, nope, it's up here. So it, you know,
Well, at least it's consistent.
only thing I can come up with. So, same thing, x equals -1 cosine of 315. What is the cosine of 315?
Root 2 over 2.
Popular number today. So this is going to be -√2 over 2. And then y is -1 sine of 315.
Negative root
So -1 times -√2 over 2, right? Yeah, okay. I was making sure you were telling me that the sine of 315 was just -√2 over 2 and not doing the other negative, because I was like, I think the final is supposed to be positive.
2.
So
I
then-
don't know. Sounds good to me.
So then that one is positive √2 over 2, so our xy is -√2 over 2, positive √2 over 2. Okay, the next one, part A says complete the table for the polar equation. So basically they give us theta, they've given us an r equals something, and we're going to be plugging in the theta values to get the r values. Then step 2 says to graph the points, but I'm not going to do that yet. We'll probably leave a little bit of space, like to do, one little thing to go back and plot them when we get to the graphing type stuff. But I was like, I don't want to graph them yet because we haven't done that stuff. I would rather work through the other stuff. So we'll just leave a spot to be able to go back and do that later. But we'll go ahead and do the table now. So 6, the equation is r equals 2 cosecant of theta. And then our table for theta and r, they give us the theta values. So the first one is pi over 4, pi over 2, 5 pi over 6, pi, 4 pi over 3, and 2 pi. And where they pulled those numbers from, I don't know, because there's no rhyme or reason to them. So basically we're taking each of these theta values and just plugging it in and solving. But obviously we're dealing with cosecant, which isn't directly on our unit circle, so it's going to require us to do a little bit of work. Now, some of them, tend to be a little easier, and we can kind of just do the work in our head for them. But some of them I'll probably actually write out just because, when you get all those root somethings over 2s and all that, it just gets a little crazy when you keep change flips. So when we put in pi over 4, so I would think of this as 2 times 1 over the sine of pi over 4. So what's the sine of pi over 4?
√2 over 2.
So because it's on the bottom, right, and I keep change flip, then that's going to end up being 2 over √2, right? Are you tracking on that? Okay. But that's a problem.
Can't have a radical.
So what do I need to do? Huh?
It's a problem child.
Yeah, it is. So what do I do about it?
Multiply by √2 over 2.
Multiply by √2 over 2. So I'm going to end up with 2 times 2 √2 over 2. So 2's cancel, and I'm left with 2 √2 going in this box. So this would make one coordinate pair. So the coordinate pair for this one that would be getting plotted is 2 √2 and pi over 4. Like if we were, when we get to the point where we're actually doing them. Now, pi over 2. What is the sine of pi over 2?
1,
1. So 2 times 1 over 1 is
2.
2. So I don't even really need to, write that down. You can if you want to, but that one's pretty chill. All right, 5 pi over 6. So what is the sign of 5 pi over 6?
1/2.
So I've got 2 times 1 over 1/2, which is
4.
4. Now the tricky one. What's the sign of pi?
-1.
0.
Oh, I'm thinking of cosine.
So 2 times 1 over 0 is
Perhaps it's 0.
Oh, it's undefined.
undefined.
Undecided.
So I would just write UND for undefined. And that just means we can't plot that one.
I was trying to say undefined before she did, and I said undecided.
Oh, well, I said 0.
All right, 4 pi over 3. What's the sign of 4 pi over 3?
-√3/2.
So this is going to be 2 times, I'm going to write this one out. 1 over -√3/2. So we keep change flip. That's going to be 2 times -2 over √3. So what is that going to end up giving us? This one is a very problem child.
Yes. Four root 3 over 6. No, wait.
Three.
-4√3/3.
-4√3/3. So we would multiply by √3 over √3. So that would give us -4 times √3, and then the √3's on the bottom become just +3. All right, at 2 pi, so what's the sign of 2 pi?
0.
So 2 times 1 over 0 is?
Undefined.
So this one would also be undefined.
So if it's divided by 0, it's undefined. But if it's dividing 0, then it's 0.
Feeding 0's on top.
Yes.
Okay.
I was like, wait, what?
That's a weird wording of it.
I know, I was like,
understood
I was like,
it. I'm-
dividing 0 versus dividing
So
by 0.
if 0's on the bottom, it's undefined.
She looked confused, so I felt the need to clarify.
Well, that's why I was like thinking that's what she meant, but then I was like, what? I was like, when is that gonna happen? I was like, it's 1 over sign, so that can't happen. You just meant in general.
Yeah. Because I always forget that rule.
I know, I mixed it up.
All right, I would just leave, I don't know if you have room on the side. I mean, you don't need a lot of room, but basically, you know, enough to do like a little coordinate plane like that. And we'll come back when we actually get into the plotting points in that regard.
Do we need to make that kind of big?
Hmm?
Do we need to make that big?
Not really.
Okay.
We'll just label this like A, B, C, D, E, F, and we'll just put a little letter on there to specify which one's which. All right, I'm going to show you one of these. So this is plot the point with the given polar coordinates. So my first reaction was to put it on something that looks like this. But that's not what we're supposed to do. So I'm just going to show you one just so you can see what we're doing. But they give us the point 2 and 5 pi over 6.
Oh, it's positive.
It is. So what we do with these is we start with the line going this way. Let me go back and find the official name for it. The polar axis. And then we're going to be drawing the pole using our polar coordinate. So where is, almost there. Where is 5 pi over 6? Quadrant 2. So it's going to be over this way, like that. And it's 2, so, you know, just drawing it approximately. So this angle from here to here is 5 pi over 6. And this length here is 2. And they call this 0 or O for the point there. And that's all you have to do. But this is where I said the ones that are negative, you have to like draw the angle, but then you have to, so they'll use dotted lines to show where it should be or like where it should have been, but then the solid line to show you where it actually is based on the fact that you had that negative in there. So, anyways, we'll look at those on Monday, and probably we should be able to wrap up this section on Monday. I think the problems seem to be a little faster. So, and then we could quiz potentially next Friday on 6-4, 6-5. So, just to get this stuff, all in one together.